speed up your shell scripts. So if you'd please give it his attention.
Thank you. Okay. Yeah, like you said, my name's EdSmeltz, and I'm going to talk about shell scripting. It's speeding up your scripts. We're going to hit this from probably a different angle than what you've seen before, and I think you'll get something out of that different angle. A lot of times when we look at the data we've got to crunch through, it looks a lot like that. We've got all sorts of stuff to dig through, and it's anybody's guess how can we get to the data we really want. What we can do a lot of times is write a shell script, a custom shell script that'll get to that data. We'll basically we'll talk about understanding computational distance, what that means, what kind of impact it has on our scripts, and what slows scripts down, what speeds them up, and different techniques and mindsets we can use to get there. Primary idea to remember is anything we ask the computer to do is going to cost it something in resources and in time. So if we can ask the computer, if we can find a way to ask the computer to do the same thing while asking less of it in terms of resource use, the script will go faster. Big thing, how can the computational distance of this task we're asking it to do be reduced? We've got a very simple equation here, and this is as complicated as the math gets, so nobody has to run towards the door or anything. Time is equal to distance over speed. Very obvious. We run into this every day when we go someplace. Distance we cover is going to be covered proportional to the speed we go, or inversely proportional to that. If we've got, suppose I got a pen, and I know a really nice store in Columbus where I can get a duplicate pen here. Well, I could go to Columbus and get that pen, or I could go to a store a lot closer. And that's exactly what we're talking about in speeding up shell scripts. The destination is the same. The effect that we're going to have is the same, but we're going to find a more direct way to go there, get there. If you want to reduce by a factor of 10 the time it takes to obtain an item, I don't need a vehicle that goes 10 times faster. I need to find a store that's 10 times closer than the one I've been going to. As this equation pertains to computers, the computational time is equal to the computational distance divided by the computational speed. Now, the maximum computational speed of any given computer is going to be a constant. At least when you push it hard, there's going to be one maximum speed it can go no faster. Because the maximum possible computational speed is generally constant for any given computer, to minimize the computational time, we must find an approach that minimizes the computational distance. For any given computer system, the runtime for an arbitrary programming approach to achieve a given objective can differ from the minimum possible runtime by multiple orders of magnitude. This is something I never heard shared. Nobody ever told me that. I found that out experimentally. Oh. While writing this book, I'm going to pass it around so you can see it. It took me 7 years to write that. I did not start out to write an 816-page book. It was going to be a little book, 1,000 one-liners, and that was going to be it. But as I was testing the one-liners, I found some that ran really slow. Okay, no surprise with that. Shell runs slowly. Everybody knows that. But I found some that were so fast I couldn't believe how fast they were. And the more I ran into that, the more it bothered me. It's like Moses in front of the burning bush. I got to check this thing out. And so eventually, I just started benchmarking every approach I could think of. At about 3 o'clock one Saturday morning, it dawned on me what I was looking at. The scripts that run faster are not the ones that consume more computational resources. It's the ones that make better use of them. So you go faster by reducing your resource use. And we'll see how that goes. Here's an example. Each of these approaches lists the prime numbers from 1 to 100,000. And as you know, finding prime numbers is a computationally intensive task. Each one of those approaches will work. And a lot of times the programs I used to write are like approach number 3. Used a lot of variables, used loops and things like that. Now, let's see how that actually looks. This is the third approach. This is the third approach coded into a test script. And I'm going to run this and you'll see, get a feel for how fast it goes. Okay. All right, you can see it's generating primes here on the fly. And it's going to run for a while. So I'm going to terminate this, and we'll run approach number 2. This is what approach number 2 looks like. As you see, it's a little bit simpler, shorter, got a lot fewer things in it. You can see it's running considerably faster. And here's approach number 1. It runs in 0.2 of a second. I hope I have everybody's attention. If the cost distance, if the computational distance for approach number 1 is like a trip from Cleveland to Columbus, and I think most of us have made that trip, so we have a feel for how much that is. If that's the fastest one, what do the other ones look like? Approach number 2 is once around the world. Approach number 3, halfway to the moon, more than. We're getting the same thing done, but we've got a tremendous difference in cost. The computational distance that we're using in this path is a lot higher here than it is on the other. One of the things we can do to speed things up is eliminate shell variables in the main data path. Every time I have to stuff another piece of data in a variable, there's an overhead for that. I am extending the distance, the computational distance. If there is a way, though, to pipe the value directly from one to another from one command to another, then you eliminate that overhead and you speed things up. As you can see, there's all sorts of ways to embed commands into other commands, and this is just a little bit. I experimented with it, and I found out that after about 3 or 4 levels of embedding commands within commands, I ran out of ideas to try. It all still worked, and it was all very fast. Another way is to use commands that lend themselves to pipelining. Here again, even though we've got a pipeline, such as, in this case, that is pipeline, obviously, but it's also an implicit loop. Every one of these commands has a looping structure in it, but it runs at compiled speeds, which means it's very fast at handling one piece of data after another. And that's where we get our speed increase. You want to minimize the number of times you start any given command. If you have a loop and you have a command that runs every time that loop runs, then you are paying the cost of starting that command. There's overhead for starting the command every time you start it. But in a case like this or that, especially this, you're starting every command only once per running of the script. And so you're cutting out a lot more of the overhead that way. Also, there's a way to greatly extend the usability of a pipeline, and that's by putting conditionals inside of subshells. You can the conventional way of using a pipeline is command, pipe, command, etc. This allows you to create what amounts to a railroad switching station. You can alter the path that data takes through any given stage of the pipeline by using subshells. And these execute at pipeline speed because, for instance, this. If this is a y for that variable, that means that the data is going to try to go through here, but it's not going to be able to because date doesn't accept pipe data into it. So all that's going to happen is the date's going to go out here. If this is a y, suppose, okay, all the data is going to go out through this path and out there, which means that this is executed only once, so you only pay for that, the overhead for that once, not for every piece of data that goes through the pipe. Does that make sense? Yes?
Can that be typed all as one line, or do you have to structure it?
That could be typed in one line if you separate by semicolons. Yeah, I just structured it that way for readability. And because my slide was only so wide. Here's a more advanced way of doing it. Same idea. As you can see, you can do just about anything you can imagine in a pipeline, as far as alternate paths, anything you want to do. Here we have 3 different approaches on how to delete the characters XYZ out of a data stream. We can do it either with TR or with sed configured this way or with sed like that. Again, we have a cost difference. Cost difference of approach number 1 is from there to there. Number 2 is from there to there. Number 3 is down to Chihuahua, Mexico. Better take your passport. Any questions so far? Okay.
Is this available in PDF?
Yes, it is. I found that a lot of times there are multiple commands that are capable of implementing or executing a given task, of carrying it out. If, for example, you are dealing with binary data, you've got a choice between octal dump here or hex dump. Generally speaking, hex dump is faster than octal dump. I just found that out by running a lot of benchmarks. And that's the case with all these. Anytime you can find something higher up on the list, if you can use that command as opposed to a command farther down there, your script's going to tend to go faster, because just by the way the command is coded and handles that particular task, it's going to go faster than another. Well, one thing that I was kind of surprised at when I looked at the move command, when you're talking about large files like gigabyte size, you can move a gigabyte size file more than 1,000 times faster. You can copy it, as long as you're within the same file system. The move is just altering some pointers in the file system table. Here we've got a case of, we're doing a find here. We're reading each path. We're gzipping that path, which it causes the data to be read up into the CPU, back to the file system, and then back up here, and then over to the destination. This allows us to read the data once, convert on the fly, write it to the destination. This is an actual situation I ran into at a customer not too far from here. That approach was costing them so much in their storage system that their computer literally could not keep up with the processing. All I did was convert from that approach to that approach, and they had power to spare. So it can be very costly if we don't think in terms of what we're actually asking the computer system to do. Here are a bunch of rules and suggestions about reducing file I/O. It's all pretty much common sense. But if you consider how slow disks are, even the solid state disks, they're a lot faster than physical disks, but there's still a cost associated. Anytime you can eliminate an operation like that from your script and make better use of the data, where it is and how it is, it's going to go faster. Here are 4 different approaches to inputting a file, generating a sorted file, and then a reverse sorted file. So we're going to have one file in, 2 files out. One's the reverse order of the other. Even though they all do the same thing, this guy runs about 9 times faster than that guy when half your data is duplicated. As you can see, the same ideas are present in this one and that one. There's just a different way of doing it. Instead of doing a unique sort twice, we cut out the duplicate lines with that. Instead of sorting twice, we sort once. And in order to get the reverse sort of the lines, we're just going to do a tack, which is cat, only it reverses the order of the file lines in the process. That is a lot simpler, it asks a lot less of the system. Yeah, I know. It's got a bunch of punny people writing these commands, but that's what it is. What it is. Any questions so far? Okay. All right. I'm not saying that this is the best way to generate a list of numbers, but I'm using this because it's a good way to see how identical commands used in a different order can come up with much different speeds. This part adds a number to the front of the line. This cuts out the Y that this puts out. This cuts out the Y that puts out and just passes on the new line, and then cat adds a number to it. We have the same data here, but not the same data across there. So since we have less data going through here, this is going to be the faster one. Any questions about that? One of the things I found is one way to greatly speed up a script is to reduce the amount of data that you're dealing with as early in the pipeline as you can. That way, you're asking less of the computer, you're shortening your computational distance, and the thing's going to run faster. Also, if you increase the data in the data stream as late as you can in the stream, that's going to help speed things up. There are certain options that you don't want to use unless you're backed into a corner and have to use them, because they greatly increase the amount of work the computer has to do. It's increasing the computational distance. Verbose option on tar, gzip, the higher compression levels, block size option on DD especially. I saw, worst case, more than a 300 times difference in speed if you do a block size of 1 as a block size of considerably more, like 30,000, 300,000, because every time DD has to go back to the disk to grab another piece of data, there's a certain amount of overhead with that. Bigger block size cuts down on the overhead. Here are some general rules of thumb. Asking the computer to do less but accomplish the same thing. Another rather humorous thing I found, the most obvious way to do something is a lot of times a lousy way to do it if you want to go fast. But one of the things you want to do, one of the most efficient ways of time that I know of, is come up with some way that works and then work on increasing the speed of it, substituting commands, rearranging things, whatever. Making best use of previous work is something that we used on that one example with the sorts. I knew that the data that was coming down the pipeline was the reverse order of what I wanted in that second file, so I just used the tac command, took advantage of what I'd already done instead of resorting the whole thing. Here's how to benchmark different things. Use the time command. There's actually 2 time commands. One is embedded in bash, and the other is a standalone executable. They work a little differently, but they give the same effect. The format's a little different. This is the internal one. Just by comparing commands, I was able to find out a whole lot of different ways to not do a shell. I found more than a factor of 1,000 difference in speeds and different approaches. And I thought, well, no wonder shell's got a reputation of being slow. If nobody's pointing out how to go fast, it's going to be slow, because our natural tendency is to stuff everything into a variable, do things to the variable, and stuff another variable, and just all that. When I give somebody a fish, that's basically charity. When I teach how to fish, that's technique. When I show somebody how to figure out how to fish, that's mindset. Mindset. Every time you go down farther in the list, the width of the benefit grows. Techniques. That's basically what we've been talking about here. The laws of math and physics don't care. We need to make programming decisions that cause these laws to work for us. After we get something that works, we need to look for ways to speed it up. If we can convert variables to not using variables, if we can pull out our loops and make it a pipeline instead of a looping structure. I'm not saying never to use loops or variables or anything. They come in very handy. A lot of times they're the only way to do something. What I am saying, though, is be aware of what it's costing you. What are your benefits? What are your costs? That's engineering. One of my favorite sayings, when all you have is one idea, you have no idea what you have. Only by comparing different approaches can we learn how much better we could do. So I found out time after time, it was very frustrating writing that book because I kept running into situations where my favorite way of doing things was often 10 to 20 times slower than other ways I found. And so it just went on from there. My default expectation for script execution time is 1 second. Now, there are a lot of scripts that can't meet that, but that's what I shoot for by default. Just last night, I ran into a situation like that. And we'll see that script work here in a couple minutes. I wanted to have a script that would generate random data from different tables of eligible items, city, state, zip, first name, last name, IP address, and a host name. My first version of that took 5.5 hours to run. My last version took 10 seconds. That's because I kept applying these ideas. I had been generating the lines across like this, and I found that if I set it up to generate all the columns of a given type, I could go a lot faster, and so that's what I did. Like I said, we'll see that in a moment. I tried to diagram the process that was going on here as I was going through the learning curve of writing the book and learning things from what I was seeing. One of the most important things about your mindset, how you think, is have points of view rather than just one. A lot of people default into one point of view and that's all they think about. That's the only way they approach things. If we can generate multiple points of view, hitting something from one angle, then from another, we can oftentimes find something for the third or fourth point of view that doesn't show up in the first one. My expectations, when I started expecting my scripts to run a second or less, I started pushing the scripts in myself to look for a better way. Is all the stuff making sense? Okay. I also had to develop some mental flexibility. I had to think in terms of there's more than one way to do this thing. There might be 5 or 6 or 7 of them. Most of them might really suck. One may be really fast. I want to find the fast one and use it. Boiling all that down, I ended up with some techniques and procedures which are fine, but there's a top end. There's a limitation on any technique or procedure. It's only what it considers. Mindset is open-ended. It can be applied to anything. If you have a good way of approaching problem solving, you can make your own procedures and methods that work, even better than the ones I stand up here and talk about. I'm only one guy. We've got a lot of really good minds in this room, and I'm sure there are a lot of potential to come up with better stuff than I got. But this is the best I got, so I share it. When we take our experiences, the scripts that we write and how they run, and feed them back into our way of thinking, we can modify our way of thinking. So What changes is not what we know, but how we think. And that's how we can continually get better and better at this stuff. It actually changes how we process information, how we attack different programming problems. And the principles, a lot of the principles I'm talking about here apply not only to shell scripting, but also to general programming on any computer program language that's command-based and is extensive enough to have multiple ways to do stuff. Anytime you have multiple ways to do stuff, one's always going to be better, faster, easier, more efficient resource-wise. Making sense? Yeah, okay. Any questions or comments? Okay, now, I made you promise. Let's see that data. This is the sample data that the script is going to generate, and we're going to generate a whole new set of it here, of city, state, first name, last name, IP address, and then a host name. Suppose that you're the security guy at XYZ company, and one of your employees brings to you a blog that says, hey, I've found a way to break into one of the 30 frontline hosts on XYZ company, and I can do anything I want. And he starts looking into this, and this guy knows things that an outsider would not know. It looks like he has been into the system. So he says he always logs in as a different name. You don't know where he is. You don't know when it happened. All you got to go off of is the contents of a file like this. How do you find them? I'll show you how. Okay, the file that we generated, or regenerated, is that guy right there. You can see it only took us about a second or two to do it. It's almost 100,000 lines long. Random data. You can see it's different from the other one. Now, how do we find out who's been breaking in? What we're going to do Now, this isn't going to tell us the guy or his name, but it will give us an IP address, which may or may not go to the guy's house. He may be ricocheting off of that IP address from someplace else, but at least it's a lead to find. We're going to take our input file. We're going to look at fields 5 on, which is the IP address and the host name. We're going to sort it, and then we're going to count how many of each instance we have of that IP address and that host name. If he's compromised one host name and knows how to get there, then that IP address is going to keep showing up with that host name. Does that make sense to everybody? Then we're going to sort the output of that by number so that the top one goes to the top, or the most frequent one goes to the top. We're going to cut it off at just 10 lines. And then we're going to take the first line, the second entry, which will be the IP and host name, and we're going to grep through that and find it. And then we're going to output those two files. Okay, our guy, I'll show you the distribution first. The most any other individual IP address has hit any host name is 4 times. Most others are 3 or less because they're hitting these 30 hosts at random. This guy's targeting this one host. How he's doing it, I don't know. This is just an example. But he's hit that host 26 times. I'd say we're looking at the guy that knows how to compromise host number 003. And he's been coming in through this IP address, hitting that host. Now we know, or have a really good indication of host 003 is the one that's been compromised. And the guy's been accessing it through this IP address. And so, and you could see it chugged through almost 100,000 lines of log file in just a couple seconds and gave us that answer. We now have a direction to go. It may lead somewhere, it may lead nowhere, but at least it's a direction. Does that make sense? Yeah. You can take unstructured data, like we did in a previous presentation, and look at frequency of letters, frequency of words, and things like that to get clues on what kind of thing you're looking for. Any questions, comments? Yes.
Do you still have that presentation for the word frequency one? When you go through that, do you still have that?
I've got that script with me, yes. You want me to run that?
Yeah. Does anyone else want to see that? Basically, was it you went to the Bible then?
Yeah.
Like the word frequencies of that?
Yep. Yeah, I brought that with me. Right, in this script, and you can see it's only a couple lines. It may be rather cryptic, but it is what it is. It doesn't take many commands to do what we're going to do. We're going to count how many lines every word is used in the Bible, and I'm just using that as a sample thing. All right. You can see that in just a little over 2 seconds, we counted every word in the Bible, a lot of them, as you can see here from these counts. So if you need a word frequency type of analysis, that kind of approach can be used, and you can see if you use a pipeline approach, you're not talking about minutes or hours to do this. You're talking about a couple seconds. When you the more you compress the execution time on your scripts, the more options, the more liberty it gives you. You can cut and try different things. If it only takes you a couple seconds, you can work it down to the point where you're not talking about much time at all, and you can tune it to exactly what you want. If your runtime is in 10, 15, 20 minutes type time frame, then it limits your options about what you can do or how much you can do it. Yeah?
Is ShellScripting your primary tool, or do you use other tools?
It's my primary go-to tool because it's so versatile. And since I went to the trouble of documenting how to do all this stuff. Oh, did everybody get a chance to see the book? Mm-hmm. Okay. Yeah, it's, in my experience over the last few years, if I could imagine it, I could do it in Shell. Now, either that means that Shell is very extensive in its ability, or I've got a very limited imagination. Take your pick.
But tell them how you use it. I mean, what's your primary job?
My primary job, I'm a consultant with Rolta AdviseX. Right now, I've got 4 customers. One of them is a 40-hour a week. They're all remote jobs, remote access. At my primary job, last count, we had something in the neighborhood of 900 Linux boxes and 200 AIX boxes, and I'm one of the primary people to maintain them. If we need a piece of software loaded on some and not others, a lot of times they'll come to me. Over the last year and a half, every script-related task they've given me to do, I've been able to do it. It's kind of funny. Within the first few days I was there, they said, we need to rename a lot of these files, these nmon log files, because they have different date formats on them. It turned out to be they had 750,000 of them. And he gave me the task at 9 o'clock. And by the time I went to lunch at 11, they'd all been renamed. They fell into 4 categories of naming conventions. I used awk as my go-to thing to focus in on those particular fields, detect what the data that was in each part of the date, resequence it, and what I did was had that generate 4 massively long scripts that would correct the name on each one of these things, and I just ran those 4 scripts, and I think I forget how fast they were running, but 750,000 in 45 minutes was pretty fast. 2 days later, they asked me if I had been able to rename the files yet. Before I went to lunch, I had sent them an email saying they were renamed, but they get hundreds of emails every day, so they just didn't catch that. But that was kind of fun. Any questions or comments or anything? Wow, quiet. Quiet group. Let me, book locker, yeah, I'll put it up there. Yeah, that URL, that's the home location of the book. But like yeah, like he said, there are other places to get it to. While I was writing the book, I was also shell scripting throughout those 7 years at different customers. And it was a funny story. There's this one customer, one previous customer, they had this one operation where they copied over 1 million files from a production machine to a development machine to freshen the data so that they'd have fresh production data to work on and test their new routines and stuff. And it was taking them 22 minutes to do it. They were using a tool like FTP or some such thing. I forget what it was. And they asked me, could I speed it up? And I said, I think so. And I converted them over to rsync. And if you've ever used rsync, you know how powerful it is and how smart it is. If the same file is already present on the destination, it doesn't mess with it. It goes on to the next file. I demoed the thing for the guy at that company that asked me to do it. The demo took 19 seconds. And you should have seen his jaw drop. And he checked it out. And, yeah, it's all there. So that was a lot of fun. So is it kind of surprising? Did it surprise anyone to find out you can write shell scripts that may run 500 to 1,000 times faster? Is that a surprise? Yeah. I've got another talk where I go down through different things that it can calculate, different text manipulations it can do. Basically, if you can imagine it, you can probably do it in shell. If you know the command, or if you got a book that tells you the command. Is there anybody in here, let's take a chance. Is there anybody in here that doesn't know shell, or they would say that their knowledge of Unix shell approximates zero, is arbitrarily close to zero? Do we have anybody in here like that? Oh, okay. Would you be willing to help me with a demonstration? Okay, this is not bad. You still got the book? Okay, I want you to find a line of code that will allow me to delete the null character. The table of contents starts on page 11. Okay, look for a chapter that's called deleting. That's a hint. What's that now?
You flashed some text up there earlier that would do that.
Not.
In the talk.
Yeah.
Yeah, you had some code up there that would do what you're asking him to do.
It's close to that. I wasn't deleting the null character, but yeah. Okay. All right. Yeah, I know it's tough to do things under pressure. Yes, it is.
Okay, page 213.
Okay, now you're looking for deleting a character called null. One of the things about the book is, on most of the chapters in section 2, the beginning of the chapter is how to deal with characters, how to deal with fields, how to deal with lines and files and so forth. It goes from small to big. Okay, start at the beginning of the chapter.
All right. First one, how'd I miss that?
Yeah.
Okay.
Right there. Yeah, you got it. That's how you delete null. Found by somebody that's not knowledgeable about the language. Hey, everybody is unknowledgeable about something. All right. The idea was this, to lay out, it took me 6 months to figure out how to lay out the book, how to organize it. And I used my wife as a guinea pig. She's intelligent, lovely person, but she's never programmed a computer in her life. I organized the data in one way, printed out, handed to her and said, honey, tell me how to delete null. She couldn't find it. Okay. I went back, reorganized, printed it out, gave it to her again. How do you delete null? Couldn't find it. And so I took it back, and one time in frustration I said, I want to delete something. Why can't there be a chapter on deletion? And the light bulb came on. So that's the way I laid out the chapters. Appending, prepending, deletion, all in alphabetical order like an index. I printed that out, gave it to her in 2 minutes. She pointed it out. And at that point, I knew I had a way of organizing that would really work. And so, oh, thank you, by the way, for your help. Yeah. Any questions or comments? Okay, I guess that does it. Thank you.
Thank you so much, Ed. Once again, if you guys are interested in giving a talk, we are always looking for more speakers. You don't have to have written